HPIE 3.0.
All right, so the panel discussion topic is genomics, a new toolkit to mitigate NCD and GBD. So we have our moderator on the stage, Mr. Ashish Rohila. He's the CEO of ARC. Can we make a louder noise and louder applause for our moderator? So let's move ahead with our next esteemed panelist. We have Dr. Anup Rawool. Dr. Anup Rawool, sir. He's the Associate Director of Medgenome. Can we have you here? Please put your hands together for him. So next, I would like to call here Dr. S.V. Prasad. Dr. S.V. Prasad on the stage. Please put your hands together for him. He's the CEO of Progenics Laboratories Private Limited. Next, I would like to invite here Dr. Shelly Mahajan. Dr. Shelly Mahajan, Lab Director of Mahajan Imaging and Labs. Please put your hands together for her. Next, I would like to invite here Dr. Rahul Solanki. Dr. Rahul Solanki, he's an application scientist at Agilent Technologies, India. Next, I would like to call upon stage Dr. Ashutosh Gupta, the head of Fetal Medicine and Genetics at Artemis Hospital. Put your hands together for all the amazing dignitaries on the stage. And thank you so very much for presenting over here. And now the stage is yours.
Thank you. Thank you. Not sure how much of you are aware and understand the intensity about non-communicable disease. Every 2 seconds, one person dies out of NCDs, and 41 million people each year are dying, and it accounts for 74% of deaths happening globally due to non-communicable disease. So it's a major and widespread problem. And when we started to categorize it in the terms of, there is a term which is mentioned in the subject line here for the topic discussion, global burden of disease. So it's like there was a study done by Harvard Publishing House and World Economic Forum in 2011 about like how it is impacting the global, how is creating a global burden of disease, and how we identify it in the terms of like how the economic value of lost productivity is being done, and then how we compare that if there is a productivity which is affected by the wrong health is coming into the picture. So we'll have an esteemed panelist today, like you'll see scientists and you'll see medical geneticists here, and people are doing diagnosis also in genomics. So we'll try to understand what are the problems happening and what genomics is doing, and then in India where it is reaching out, and how we can maybe come to a conclusion where it can be a part of public policies moving forward. So we'll have some discussions, but let's understand from the esteemed panelists here, like what's the role of genomics in NCDs, and ultimately how it will ease the global burden of disease. So Dr. Anup, first you.
Thank you, Ashish. So first, let us understand what is NCD, non-communicable diseases. We all know heart attacks, coronary artery disease, atherosclerosis, hypercholesterolemia we talk of diabetes, obesity. And so all this category of disorders are non-communicable diseases. So in India, at present, more than 50 million people are affected with non-communicable diseases. And so if you talk of coronary artery diseases, so in general population, so you can categorize them as, say, diabetics and non-diabetics. So how these disorders are related. So in people without diabetes, 10% having non-communicable disease in form of coronary artery diseases, and in diabetes it's double, 20%. So when we talk of genomics, so we talk of inherited diseases, right? So again, there are some genetic markers at the level of DNA which influence the risk for these non-communicable diseases. So that's how it is important. And now, as Ashish mentioned, studies have been done. There are markers which you actually can test, do a polygenic risk score, and in general population, you can predict the risk, okay, for this particular individual. If I'm talking of coronary artery disease, over the next 10, 15 years or 20 years, what will be his risk of having a coronary artery disease compared to the general population. And similar polygenic risk scores are available for, say, diabetes, for obesity, even for something, you can also calculate your biological age based on such tests. So what is your chronological age and what is your biological age? And there are tools available, techniques available, tests available to do such kind of tests. So what was deemed that non-communicable is a multifactorial, but in that also genetic risk component is very significant, and there are ways and means to quantify it.
Yeah, just to add to it, there was like pathological or, diagnosis earlier, and where like certain markers are there, and then when the score is there, I'm not sure how many people are aware that genomics is providing that facility by which you can predict maybe what are the problems, how susceptible you are to the problems and the diseases.
See, basically when you talk of genetics, as a medical geneticist, I can divide conditions in two categories for common person to understand. So one is which are purely inherited, right? You see the condition going on in generations.
Yeah.
So inherited conditions, genetics, that's easy to understand. And second, those conditions that we are talking of, say heart attack, hypercholesterolemia, diabetes, obesity. So we find some clustering in families, which is there. Okay, father is obese, child is also obese, some inheritance pattern. Then there are certain genetic markers which give you one-to-one risk. If that genetic abnormality is present in that individual, he will have that disorder. Passed on to the next generation, that person will also have the disorder. So these are inherited conditions, monogenic disorders or Mendelian disorders that we talk of. Then comes non-communicable diseases. So in this also, there are certain genetic markers. If you have those polymorphisms, so they increase your risk or propensity to developing that condition. So if we study these markers, we can give a relative risk. So as I mentioned, you have a polygenic risk score. Medgenome lab does the test. It looks at about 1.3 million genetic markers, and it takes calculates the risk score based on your age, geographical profile, and other details that are taken. And it will give you a risk score, a relative risk of you having a coronary artery disease compared to the general population. So it is like 2 times, 3 times, 4 times. This is given as one of the components. And again, there are ways and means to mitigate it.
Right. So when we talk about genomics, data plays an important role, like how many, what's the geography we have sequences, and what's the data available for the majority of population, how they behave and all that. I was speaking to Dr. Prasad, and he is like a very, very great supporter of having data interoperability and sharing across geographies. Many international companies from US are doing it. Like why they are leading is because they are having huge database, because they have done research on so many people. In India, the data is in silos right now. So your thoughts, Dr. Prasad?
Yeah, thank you, Mr. Ashish. In continuation to Dr. Anup, as he told that, some lakhs of markers they take into consideration for giving an insight on likely risk in your life kind of thing. So this is a kind of the database that India has set. I take Medgenome to represent India because they have a good number of exomes to compile this. Okay, having said this, still India is not completely covered, right? If you go to now, some parts of India, it is a hot temperature. Now it is, I think, less than 10 now. So similarly, if you go to some areas of some tribes of Chhattisgarh, they will have different set of thalassemia genetic profile. And if you go to some parts of, Northeast, they will have different set of genetic markers in their thalassemia profiling. This is an example, like, for every test kind of thing, like, you should have done, like, a cumulative kind of study, like covering most of the populations in the different patches of India, So that will give much more information so that the markers, whatever he is referring to, will be having much more sensitivity. So these kind of studies should be done very much, and also like private and public partnership should come into picture, so that no one person can cover entire India, because the population of India 140 crores. So it should be like public-private partnership in that, and also several people like Medgenome, like Progenics, and then many other companies can come together, and we can share the work and establish good database, so that we will have a much more indications to the general population.
Dr. Shelly represent Mahajan Imaging, and I was speaking to her. She is more into diagnosis, and they do a whole range of pathology and genomic analysis and all that. And I was asking this question to her earlier, that what she has seen when doctors are recommending genetic analysis and all that, when it's happening with the patients, result is coming out. So what's happening at the ground level, what people are like responding that if I have done that analysis, how much satisfied I am, or what are the takeaways, what they are taking, and also is it helping, maybe we'll go to the next round also for that discussion, how the preventive medications and personalized medication is happening in that direction. Your thoughts on that?
So I'd like to say that the kind of patient population we as a country deal with is somebody who's A, paying out of their own pocket, and B, is usually skeptical about a high value test.
Right.
So I'm coming from a radiology standpoint also, or a genomic standpoint also, and not just routine pathological investigations. So what the patient is looking out of that report is something coming out to be positive, which is actually, like we joke as with the patient, like if, for example, डॉक्टर साहब MRI में तो कुछ आया नहीं, क्या फायदा वो कराने का? So we say यार खुश हो ना, नहीं आया तो. So I'm just talking about the mindset of the patient, that why was I asked to do this test. Now when I talk about genomics in particular, majority of the reports will have no pathogenic findings. But to put that information to the patient in the context that even a negative report may have an implication in your therapy, a negative report may have an implication into your family. So what's lacking here maybe is a good pre-test genetic counseling and post-test genetic counseling. A genomic test cannot be treated as any regular MRI or a regular test, and it cannot be commoditized like that. It has to be something which has to be explained to the patient, because in terms of what a positive report means, what a negative report means, or what a variant of uncertain
Absolutely
significance means. So that is one thing. And secondly, also what kind of panel we are suggesting for the patient. I mean, a whole, like for example, just a simple diagnosis of maybe diabetes or a simple diagnosis of breast cancer does not mean that every breast cancer patient should get a particular somatic panel done. Yeah. Just as an example. So, so a lot of, I mean, we are taking baby steps, we are moving forward in that, but still I think there is a lot of awareness which needs to be, created amongst healthcare professionals, and a lot of interaction is required between maybe a pathologist and the clinician who's writing the test, just so that we are selecting the most appropriate and most crisp panel for the patient, so that the patient, the probability of some information, some useful information.
Yeah, and there is huge risk also. You cannot tell, you cannot do the wrong diagnosis, right? And then when you're doing genetic diagnosis and you're telling that, okay, Dr. Ashutosh was mentioning that some patient was diagnosed with something and then he was not able to live a healthy life, and then there was some research done in the US. They suggested like the screening from the scratch again, and while doing that screening, it was identified that one particular gene was missing. So it also happens like we, as a end user, people don't understand that, but medical genetist and genetic counselor should suggest that, okay, this is like the approach is, and then that's also happening in pathology and other diagnoses that, okay, you have to start everything from the scratch. And then since these are very expensive tests to be done, and then people consider that it's an authority that, okay, it's given to us that this is how I'm going to live maybe rest of my life or maybe rest of the year. So your thoughts on that, Dr. Ashutosh?
What I believe is that the genetic tests, they have to be very, very, the specificity, they need to be very high. And the technology by which these tests are being done, they should be absolutely of a very highest standards, as a matter of fact. And you really cannot miss on not identifying one particular gene or reporting it. You cannot have false negatives and you cannot have false positives. Because these are, they do have a lot of stigma associated with them.
Yeah.
They have a lot of lifestyles, and meaning thereby they really can change the altogether the scenario to the life, as a matter of fact. Okay, somebody as a man, somebody with some conditions, if you identify that he is a BRCA2 positive or a female who is a BRCA1 positive, so meaning thereby that you need a lot of counseling sessions, you need actually to make them really understand that how this one particular one test and diagnosis can change the entire perspective for their own life first. How do they live, and what all surgeries and preventions and preventive strategies. So meaning thereby that the test actually should be done, have very high standards, as a matter of fact.
Just to add, like,
Yeah.
if you're talking of a genetic condition, it's
Right.
not the individual, but the entire family, first degree, second degree relatives, extended family, for which the repercussions and implications will be there. So you have, suppose, for example, let's look at the data. So inherited cancers and other cancers. So what's the population of Delhi? 3.3 CR, 21% female population, somewhere around say 80 lakhs. So WHO says 1 in 8 female will get breast cancer.
Right.
So that's the extrapolation. So I extrapolated to this 70, 80 lakhs. So that comes out to be how much? Another say 80, 85,000. So there are at least 1 lakh women in reproductive age group in Delhi alone who are at risk of breast cancer.
Right, right.
And 5 to 10% of them are inherited. So if I take say 5% of this, so out of 80,000 I am taking 5%, maybe around 4,000, 5,000 individuals, maybe more. So the range is 5 to 10. So out of those 8,000 or 5 to 8,000 women who are at risk of inherited breast cancer, it will have an implication on their family as well. So there are going to be other individuals who are going to be at risk of breast cancer, ovarian cancer, pancreatic cancer. If it is BRCA2 male breast cancer, prostate cancer, implications are going to be huge.
Right. So one great example you mentioned about that Michael, like the foreign celebrity, he had
George
some
Michael,
issues.
George Michael died, I suppose, at the age of 45, 44, 45, right? And it was a huge blow, right? Nobody could understand why did he died. And then he died because then there was an extended weekend and all those stuff. And then probably it had come in the newspapers. Then the body was exhumated because I suppose he was a. And then they did the panel and they identified he was a DCM. He was a dilated cardiomyopathy carrier. Right, had it been those tests would have been done earlier, so probably we could have identified that probably you should avoid doing those recreational drugs or cocktail. So that would have led to an oxidative stress. Similarly, I suppose this would have happened with Shane Warne also. Shane Warne in Gurgaon, right? Right, hai na? So he was on a water therapy and all this stuff. It is not about the water therapy. It is because you make a lot of reactive oxygen. So anybody dying less than 40, like you are. Anybody with the name of S, as I believe, Shushant, Shrikant, it is just a joke apart, but 40, 45 years, healthy people, they're dying suddenly, all of a sudden less than 40, 45 years. Traditional thinkings, you really cannot explain, like you have had those clogged arteries and therefore you landed with an MI, but probably you are having some genes which made you susceptible for cardiac arrhythmias, and because of the environmental influence and insult, you landed up with a very severe sort of an arrhythmia from which you were not able to recover.
So just to add on to this, Indians are having MIs, coronary artery disease, at much younger age than the Caucasians.
Yeah, there was some
The
stats also, right?
Risk
Before
is
the
3
age
to
of
5 times
70,
higher.
people
3
are
to 5
dying.
times higher for Indian population.
Right.
So that makes more sense to go in for genetic screening tests.
Right.
I
Dr.
think
Rahul,
just to add, I think everybody knows about Angelina Jolie. So she got her BRCA test, and she got her therapy started. So when it was way back, I think 6 or 7 years back, when NGS was pretty new.
Right.
Yeah.
Then you have to add just to add on to it, the Angelina Jolie promoted all this BRCA1 wali study, right? But Firoza Parekh, she is the leading IVF consultant in Mumbai. So there was one lady who was a BRCA1 positive, right?
Right.
So she have had her IVF being done, and then the embryo biopsy was being done, and then she got all those ET and embryos being implanted, which was BRCA negative. So meaning thereby the science can really lead to that particular stage. If I'm a carrier, I underwent an IVF, I made some 8 eggs, eight embryos, and then I did the embryo biopsy and then identified, and then probably those embryos were transplanted which were BRCA negative. Right. So meaning thereby that she was able to, because it is BRCA, it is autosomal dominant, 50% is there could be the risk. So, but probably the science can lead to that particular stage.
Right. Dr. Rahul, yeah.
So more towards liquid biopsy.
Very much interested, you were mentioning about cancer and liquid biopsies, and innovation are happening in Agilent technologies and across the world in genomics. Your thoughts on that?
Yeah, so on the same line, what we were discussing, so I closely work with Tata, Hackback and all. So way back, we started working on liquid biopsy. When we started on NGS 10 years back, so
Right.
doctors were like, NGS kya hota hai, hame nahi karna. For us, Sanger is the best,
Yeah.
Now they don't validate the results using Sanger. They trust on NGS. And then there is the era of liquid biopsy, especially in the case of cancers, wherein you start with the blood, you don't go to the tumor. And before the onset of tumor, you take the blood, and in the cell-free DNA, you have a cell tumor DNA, So in this regards, you detect the cancer way early before the tumor arrives.
So I think we have very less time today. We kind of need to conclude giving in the direction as objective, like where we are in the genomic era in India, and what thoughts government should take, like maybe if we have to implement it at a public level, because whatever the marketing strategies are happening, B2C customers are not able to understand what genomic test needs to be done and all that analysis. Genome Patri, like, okay, you can get the stuff, but what's the output out of that diagnosis, and what government should take, say 100-bedded hospitals and all that? Do you think there should be like some departments or specifically into that, or what are the things, what are the immediate measures we need to take in that direction, starting from,
I believe that if we divide the body into 7 to 8 systems, right, with every system 10 to 15% of the conditions, clinical conditions, are absolutely genetic. You talk about diabetes, MODY. You talk about cardiac arrhythmias. If you talk about cancer, hereditary cancer, so 10%.
Yeah.
Right. If you talk about ulcerative colitis, we do have markers in which they can say that you are susceptible. You can talk about colon cancers. We do have those markers, HNPCC and Lynch. So making those genetic diagnoses and thinking beyond clinical. Clinical was being done when these genetic tests were very expensive. Now with the advent of the technology and post this corona, this NGS has come up into our clinical practice, that within 20 grants, 25 grants, it is something like very, very nominal, in which we can screen the whole people out, and then we can identify what is the risk for the genetic conditions, right?
Dr. Rahul?
So I think I spoke what I wanted to convey, but yes, with the era of NGS, everybody knows about this. Initially, with Sanger, it took almost 13 years to sequence first human genome. With the advent of NGS, now you can sequence almost 60 human genomes in deep coverage,
Right.
And initially with Sanger, we invested close to $3 billion, and now you can sequence the same human genome with $500, And then talking about detection, so as Dr. Shelly was telling, so main thing is, and Dr. Anup was telling, main thing is the genetic counseling, what test to refer. I've seen many doctors, recommending karyotyping at the same time microarray. So microarray is pretty expensive. So Dr. Anup, your comments on this?
So the point is the burden of genomic disorders in India is huge given the population, and it is unique to the Indian population.
Right.
Unique in the sense the type of disorders, genetic disorders that we have, and the molecular abnormalities that have been found in the Indian population, they are unique. So we need to have an Indian database, what Prasad sir was saying, and indeed work is going on that front. One is IndiGene project and Asian Genome project, where Medgenome has taken initiative, databases are being created. What is important is creating awareness amongst the doctor community and amongst the masses.
Right.
What is the disorder? Is it genetic? If it is genetic, what is the underlying abnormality and what is the appropriate test to pick it up? Otherwise, what happens? Abnormality is there, but you're doing a wrong test, which will not pick up the test, the abnormality, and the clinician ends up being frustrated. I can see the condition, I can see the diagnosis, but the test is negative.
Dr. Shelly, your thoughts on this?
Yeah, so obviously genomics is revolutionizing our understanding of molecular basis of disease, be it oncology, non-oncology. But to add to that, what I would like to say is that yes, we are taking baby steps towards understanding the genotype side of things. Um, uh, but we need to understand also that it's more complex than that. There are multiple layers of genomic data which needs to be compiled together and reach a conclusion of what is the role of environment
There are many branches are
in
coming,
all of
right?
this. Yes, so it's definitely much more complex than what we know today. There is a lot of things we don't know about genomics, and that is the research side of things. To implement those research findings into clinical, we do need a lot of intervention from the government and private institutions alike, and we do need a lot of legal and ethical guidelines to be put
Absolutely
in
right.
place, like who owns the data, who has the right on the data, who is responsible if something goes wrong with any kind of implementation. So yes, we have come a long way, but there is a longer way to go ahead, which, I mean, I don't think we even know where we want to reach
Absolutely
today.
right. Yeah. Prasad.
Just I want to add further, like we are talking about the preventive measures. Mostly we are talking about the present preventive measures. The onset of diseases already we can do what best we can do to the patient. But during the talking about the preventive measures, as Dr. Ashutosh and Dr. Rahul and Shelly and Anup has already explained. To add on to that, actually, some of the government initiatives, for example, Telangana government, some few years before, they have started health cards. So it is like, every individuals, they want to make a kind of, health reports, just make it as a card. So that'll be useful for their any incentives or any government schemes they want to disburse to the public. That will be a standard for them. So in that, even there were also discussions going on, like, they also want to include a genetic information in that.
Right.
So any such kind of initiatives will be very much useful for the public. And on top of that, we have talked about the cardiological disorders and oncological disorders and neurological disorders. And one more important thing is gut microbiome also should be integrated along with this clinical exome data, whole exome data. This is also causing a lot of influence, because any individual's health is our deterioration of health starts from the gut. Means it's improper digestion of the gut. Nowadays using different algorithms. We also started establishing algorithms.
Right.
Based on that algorithms, we can tell that, okay, this person is having oxidative stress. This person is having stressed cells. Based on the mitochondrial genes which are
That's
available.
also one of the amazing output
Yeah.
when we do genomic analysis, gut microbiome and that study, and then what are the
And also based on the
probiotics.
microbial composition available for each individual is different. For example, if in India, there are still, it's in a blessings in disguise, we can say, because there are still untouched populations in India, like in tribes.
Right.
So we're also associating with a couple of the anthropological survey, wings. So we are getting the data, and so we are also trying to establish this reference data for the any healthy gut flora. So based on that reference, we also can indicate, okay, this guy is having this problem. He's also losing this kind of bacterial population. So you can just give that particular bacteria to seed into the gut so that he will recover from the gut.
Right.
Good health. One more thing is there are almost 8 or 9 stool banks in the world. These stool banks are, to implant in the healthy individuals, ill-healthy individuals. These stools are recovered from the healthy individuals. So this is called as FMT. I think many of you people are aware. Fecal microbiota transplantation. This is giving very good recovery for the particularly Alzheimer's disease. There are several reports. So we are also establishing such kind of data. Without having data, we cannot directly experiment on those kind of things. So these are also very much important topics to make any kind of policies to implement.
It's a huge topic. I think even if we speak for 3 days, 4 days, a week, forever, it will never end. But it's irony that we have less time today, and I thought that so much of questions to ask, so much things to discuss, and to the audience.
One important point which needs to be discussed and pointed out is based on the genetic data, discrimination against individuals. So there are rules and policies in US and in Europe. We are very, very far behind. We have already gone to a level where we are doing whole genome sequencing under a day in few hours.
Right.
For first human genome, it took 20 years.
Right.
We are doing it in 6 hours now.
Yeah.
So that is where we have reached. And in country like India, where there is huge potential, we need to have policies to implement, to guide, to monitor. So data privacy is one thing, discrimination is other thing,
Right.
and there are a lot many aspects.
And also how those processes are being done using digital technology, providing them, as you was mentioning for the US thing.
No, it is for Dr. Prasad. This fecal transplant is being done very regularly in our hospital as well as in Medanta. So liver transplant people not recovering even though the livers are, so they are doing a fecal transplants. So fecal transplants are being done. So clinically, so they have identified it is irrespective of not doing the genomics on the gut bacteria, but the fecal transplants are being done clinically. So they have identified very good clinical results out of this thing.
Yeah, that's what, without having a proper gut microbial data, going for FMT.
No, that is really true, but they have identified the clinical, they have identified, the clinicians have identified the clinical identifying this thing.
Yeah.
It's okay.
Thank you.
Yeah, he was asking. It's okay. Thank you, everyone, for coming here and then making this panel so amazing. Thank you.
So now I would like to call here Mr. Afzal Kamal sir and Manish Rastogi sir to please come up on the stage and order all of the amazing dignitaries who have shared the platform with this panel discussion over here. So now I would like to invite here Mr. Ashish Rohila. Please receive this small token of appreciation, the moderator of the discussion panel. So Mr. Ashish Rohila, he's the CEO of ARC. Please put your hands together for him. Come on, everyone. Next, I would like to call here Dr. Anup Rawool, Associate Director of Medgenome. Please come up on the stage. Whether he's on the stage, please come forward to receive this small token of appreciation. Please put your hands together for him. So next, I would like to call here Dr. S.B. Prasad. Please come forward. He's the CEO of Progenics Laboratories Private Limited. Put your hands together for him. So now I would like to invite here Dr. Shelly Mahajan, the Lab Director of Mahajan Imaging and Labs. So put your hands together for her. So may I invite Dr. Rahul Solanki. Dr. Rahul Solanki, he's an application scientist, Agilent Technologies, India. Put your hands together for him. Now, I would like to invite to come forward here Dr. Ashutosh Gupta. Dr. Ashutosh Gupta, he's the head of Fetal Medicine and Genetics at Artemis Hospital. Put your hands together for him. So, can we have a group photo? Indeed, it was a very amazing session over the all. Thank you so very much for your precious time.